Just like with any technology, right? When you call and they're like, "Well, did you try unplugging it and plugging it back in?" All right, evaluate each expression. We're going to pick up where we left off yesterday with a third example here. And for our third example, let's take a look at capital arc sine of square root of 2 over 2. Okay? Capital arc sine of square root of 2 over 2. Now, this isn't necessary for you to do, but it might be helpful to identify, first of all, the domain and the range for capital arc sine. And maybe more so just so you become familiar with the domain and the range of functions like this. Okay? The domain is -1 to 1. Right? We're plugging in a ratio, and ratios for sine always have to be between 1 and -1. If you think about it, it should make sense because sine is opposite over hypotenuse, and there's no way the opposite side of a triangle can be larger than the hypotenuse. The range -π/2 to π/2. Which really means on our unit circle, we're looking at what part of the unit circle? Well, be careful how this is written. We're starting at -π/2 and going to π/2, right? Passing through 0, right? 0 is in this interval. So starting at -π/2 and going to π/2. We're looking at that half, the right half of the unit circle. These are the angle measures that are going to have angle, or that are going to be between -π/2 and π/2. So where on the right half then is the y-coordinate, right? Sine is the y-coordinate. So where on the right half is the y-coordinate, radical 2 over 2? It's going to be at this ordered pair, which is 45 degrees. But we want that in radians, right? So that's going to be 45 pi over 180, which reduces to pi over 4. If you think about it, it should make sense. It's halfway between 0 and 90. Halfway between 0 and half of pi is quarter pi. Questions there? All right. Fourth example. Capital arc tangent of negative radical 3 over 3. Okay. Capital arc tangent of negative radical 3 over 3. What's the domain and the range for capital arc tangent? Nothing. Domain is -infinity to infinity. If you think about tangent, tangent goes up forever and down forever, right? So tangent's range is -infinity to infinity, so arc tangent's domain needs to be the same. And the range is -π/2 to π/2 exclusive. Which means really this range is essentially the same as this one, just without the endpoints. So again here we're talking about the right half of the unit circle. Now logically reasoning, this takes a little bit more effort though. because tangent is not one of the coordinates on the unit circle. How is tangent related to the coordinates on the unit circle? It's y divided by x. So I need y divided by x to end up being negative square root of 3 over 3. Okay. All right, so it's got to be at the bottom. Why? Because it's negative, right? Tangent is positive in quadrant 1 and negative in quadrant 4. So it's got to be down here somewhere. I can narrow it down to two choices. It has to either be at 330 degrees, which is which is square root of 3 over 2, comma 1/2, comma negative 1/2, I should say, or 300 degrees, which is 1/2, comma negative square root of 3 over 2. Right? And I can narrow it down to those two choices because I know it has a square root of 3 in it. So how about if we guess and check? Pick one of those 2 points. Which one do you want? 330 or 300? 330? Okay, so if we check the 330 degrees, 330 degrees is the ordered pair radical 3 over 2, comma negative 1/2. Y over x gets us negative 1/2 over square root of 3 over 2. 2's cancel. Negative 1 over square root of 3. So that's negative square root of 3 over 3. Is that what we wanted? Yes. So our solution here is indeed 330 degrees, written as a radian measure. Multiplied by pi over 180 degrees, we get 11 pi over 6. Yep. Bailey. Okay, so the ordered pair I choose is based upon what my ratio is. Okay? So, for example, for question 3, my ratio was radical 2 over 2, and we were talking about arc sine. Well, the unit circle, sine is the y coordinate. So I was looking for a y coordinate of radical 2 over 2. Okay? And so it was based on that ordered pair. Down here it was a little more complicated because tangent is y over x. Right? So it's not I'm not looking for the x coordinate or the y coordinate. I'm looking for a combination of the two, the ratio of the two. And so we were able to deduce a little bit. Because this is a negative ratio, I know I have to be in quadrant 4. Because here I have positive x, positive y, so that'll end up being a positive ratio. Down here I have a positive and a negative, so that'll end up being a negative ratio. We also know that there's a radical 3 in our ratio. So it has to be one of the two ordered pairs that has a radical 3 in it. So we're just kind of narrowing down our choices. Does that make sense? Okay. And from there, then, we just pick one and see if it works. Had we chosen the wrong value here, we would have ended up just getting square root of 3. Well, negative square root of 3. And then we know it has to be the other one. So we tried 330. We took the y coordinate divided by the x coordinate, and that simplified down to what our ratio needed to be. So we know that it has to be this angle measure. Does that help? Okay. Are there questions? Sammy? There are not a ton of domain and ranges to memorize, honestly. Okay? Here are the ones you should know. You really need to know the ranges for the arc functions. Okay? And it may be even better just to associate them with specific parts of the unit circle. Sine and tangent, or capital arc sine and capital arc tangent, deal with the right half. Negative pi over 2 to pi over 2. Capital arc cosine deals with 0 to pi, so it deals with the top half of the unit circle. Okay? And as long as you keep those straight, that should be enough. I mean, if you needed like the restricted domain for like capital sine of x, Well, its domain will be this range. So I wouldn't spend a lot of time memorizing a whole bunch of stuff. I would memorize what I needed to memorize so that I could deduce the rest of it. That's just me. Does that make sense? Okay. Other questions there? No other questions with number 4? No one's going to ask me why our solution is not a member of the range? That's a good question. Why isn't it? Our range is negative pi over 2 to pi over 2, right? 11 pi over 6 is not between negative pi over 2 and pi over 2. If you ignore the pi, here, negative a half to a half. 11/6 is not between negative a half and a half. Yeah, we need a smaller one. 11 pi over 6 is this angle measure here, right? If we're talking about angles like negative pi over 2, that's not a counterclockwise rotation. Negative pi over 2 is a clockwise rotation. We really need this angle. Not quite. It would be negative pi over 6. Okay? Algebraically, I can do so by finding a coterminal angle by subtracting or adding 2 pi. 12 pi over 6 is 2 pi. Now this was too large, so I need to subtract 2 pi. And so that's going to be negative pi over 6. Realistically, these angle measures down here, when we're dealing with this range, negative pi over 2 to pi over 2, realistically, these fourth quadrant angle measures are just going to be the opposite of whatever degree or angle measures directly above them, because it's the same amount of rotation, opposite direction. So you could use the top corner and recognize that if you need it to be negative, it should be negative. Okay, or if you needed it to actually be in quadrant 4, it needed to be the negative. Yeah. Yep. No. Actually, we never deal with quadrant 3 when we're talking about these restricted range problems. Because not with the third quadrant, no. Because arc sine and arc tangent are always the right half, 1 and 4. Arc cosine is quadrants 1 and 2. Okay. And arc cosine is 0 to pi, and those are the values that you are given on your unit circle. You're given from 0 to 180 degrees. Okay. Other questions there? 20 minutes, right? I've got time for probably one more here. And then we'll go on to the last type of problem. You're bummed that we only have 20 minutes left? I'm sorry. Example 5. The cosine of the capital arc tangent of square root of 3 minus the capital arc sine of negative square root of 3 over 2. Yeah, yours has to be Friday. Piece by piece, let's do it. What's in parentheses first? So let's evaluate each of these first. Which one do you want to do first? Arc tangent of radical 3 or arc sine of negative radical 3 over 2? Arc tangent, okay. All right, so capital arc tangent, the range. The range here is negative pi over 2 to pi over 2 exclusive, which means we're dealing with the right half of the unit circle. And we want y over x to be radical 3. Okay. All right, well, it's a positive ratio, so I know it's one of these two. Try 60. Oh, last time we had square root of 3 over 3, right? And that was the 30-degree reference angle. So this one should be the 60-degree reference angle. Hey, just to alleviate any fears that people might have that the logic doesn't necessarily hold up for you, y over x here would be radical 3 over 2 divided by a half. Denominators cancel. Leaves us with radical 3 over 1. So that's for this ordered pair here, which is 60 degrees, or in other words, pi over 3. Nice thing is the unit circle I'll provide you with has the radian measures on it. Right. So the arctangent of radical 3 is pi over 3. All right, capital arc sine. Before I do this one, any questions on that one? Yeah. Okay, so the range being negative pi over 2 to pi over 2, negative pi over 2 is here, and pi over 2 is here, right? And between any negative number and a positive number has to be 0. And our unit circle 0 is here. So it has to be from here to here, negative 90 to 90, passing through 0. So it has to be that half. Okay. What's the range for capital arc sine? Negative pi over 2 to pi over 2. In other words, it's still the right half of the unit circle. It's the bottom, because this is our y-coordinate. We want our y-coordinate to be negative. And let's see, the y-coordinate is negative radical 3 over 2 down here. So this would be 1/2 comma negative radical 3 over 2. And that is negative pi over 3. Say what? That would be 300 degrees. Okay. So really it would be, 5 pi over 3. But it has to be negative pi over 3 because 5 pi over 3 is not in the range. It's got to be that negative rotation. So this is negative pi over 3. Oh, be careful. No, they don't. Hello. Sure. Yep, 300 degrees times pi over 180. That's how we get 5 pi over 3. Right? We have to subtract 6 pi over 3. We have to subtract 2 pi. Or, if it's 300 degrees, then this rotation is negative 60 degrees. And if you take negative 60 and convert to radian, that's the negative pi over 3. Because you need that angle to be in this interval. Okay? Which would be negative 90 to 90 if we were talking degrees. Lauren? Yes, they would, because one's positive, one's negative. What was this angle? 60 degrees. Okay. All right, so we now have the cosine of the quantity pi over 3 minus negative pi over 3. Right, we plug in what we know the arctangent of radical 3 to be. We plug in what we know the arcsine of negative radical 3 over 2 to be. So this ends up being the cosine of what? Yeah, this becomes addition then. So pi plus pi is 2 pi, so the cosine of 2 pi over 3. All done? Thank you, ma'am. Where did I get the red pi over 3? The red pi over 3 was the value of arctangent of radical 3. Does that make sense? Okay. All right, cosine of 2 pi over 3. Go back to my unit circle. Where's 2 pi over 3? 120 degrees. And at 120 degrees, that's negative a half radical 3 over 2. So what's the cosine of 2 pi over 3? Negative 1 half. 2 pi over 3 times 180 over pi. On your unit circle, it'll give you the angle or the radian measure. You won't have to look that up. It'll give you the radian measure between 0 and 2 pi that corresponds to that angle measure. It'll say 2 pi over 3 on there. So make sure you look at the right point. All right, well, that was a lot of math to get to negative a half. I wonder if we're right. Oh, hey, I know! This is a function, isn't it? This is a function, isn't it? And we define the ranges of these functions based on what our calculator showed us as the graph, didn't we? Oh, yeah! Hey, wait, this is the cosine. Let's see. Does the mode matter here? Well, for this one it doesn't, but radian mode's probably the safest here. Cosine of the quantity tangent inverse of radical 3 minus sine inverse of negative radical 3 divided by 2. I need a extra parenthesis here. Right? Trick is make sure you put the parentheses where they need to go. Oh, negative a half. How about that? Say what? Because arc sine and sine inverse are the same thing. Okay. Okay. All right. So I need to be a little bit. I need to make a confession here. Earlier this semester, when we were talking about tangent inverse and sine inverse and cosine inverse as a way to solve right triangles and whatnot, I wasn't completely forthright with you. Okay. Because I told you that on your calculator, they typically put the inverse as the second function of whatever button. Okay? Which, to an extent, is true with trig functions, but not exactly. Technically, sine, cosine, and tangent, these are what we defined as little sine, little cosine, little tangent. The functions with the unrestricted domain, the wave that ran forever left and right. And you saw that on your graph. If you graph y equals sine of x, you see it run forever left and right. Okay? Really, though, sine inverse, cosine inverse, and tangent inverse on here are the capital sine inverse, capital cosine inverse, and capital tangent inverse. Yeah, because your calculator only deals with functions. It will only give you out one answer. So really, when you punch in sine inverse, it's really the what your textbook denotes as being the capital sine inverse, which in this case is great. Okay. Now, what about the other option? What about our other problems here then? Because those had capital functions as well. Capital arctan of negative radical 3 over 3. Tangent inverse of negative square root of 3 divided by 3. Yeah, it's that, right? Is that negative pi over 6? I suppose I could check my answer this way, right? Or, what if I go to degree mode? It'll give me the degree measure. Now, I don't want to put that as my answer, right? But I could convert that degree measure to negative pi over 6. Why didn't we do that earlier? That's a good question, Jalen. The reason we didn't do that earlier is because I want you to be able to answer questions like this. True or false? Well, no, that's the first part. I'm going to ask you a second question. Capital sine inverse of little sine of x is equal to x for all x in the domain. For all. There you go. Okay. So true or false, capital sign inverse of little sign of x is equal to x for all x in the domain of y equals sign of x. If it's true, prove it. If it's false, provide a counterexample. Right? Because for this to not be true for all x, then I have to be able to find a value for x that doesn't work. Okay? And you cannot prove something via exhaustion. In other words, you can't say, I tried plugging in 32 billion different values for x and all of them worked, therefore it must be true for everything. It doesn't work that way. Well, let's see. Little sign, that's on our calculator. Capital sign inverse, that's on our calculator. So you could try some values and see if they work. Now, what do I want to plug in for x? Angle or ratio? Angle. I'm taking the sine of that, right? So this is an angle. So are there angle measures that I can plug in that won't give me the same output, right? If I pick something for x, I don't get x. Let's try some values. What mode am I in? I'm in degree mode. That'll be fine for now. Let's try that. Capital sign inverse?
It's true, I tried everything.
Of sine of 90. Okay? So if this is actually false, then hopefully this gives me something other than 90. Nope. Okay, let's try a different value. 0? Well, it gives me 0.
It works for...
Yeah, because my calculator is not an idiot. All right. 36,000. Oh. 36,000 degrees gives us 0. Okay, so true or false? Okay, this is false. Okay, so here's our counterexample. Let x equal 36,000 in terms of a radian measure would be 200 pi. So let x equal 200 pi. Then sine inverse of the sine of 200 pi. And I'm going to do this one step at a time. This will be capital sine inverse of, well, the sine of 200 pi. 200 pi is coterminal with nothing, or with 0, or with 2 pi. Because it's 0 plus 2 times 100 pi, or 2 pi times 100. So this is going to be the y-coordinate at 0, so that would be 0. And sine inverse then of 0, well, if I have a y-coordinate of 0, the angle there between negative pi over 2 and pi over 2 would be 0. And that is not equivalent to 200 pi. Well, if you need to provide a counterexample, then yes. Now let's look at why. Okay? Let's look at why this is the case here. We have sine inverse of x, and we have sine of x. What is the domain and the range for each of these? Okay. Let's start with just sine of x. Sine of x is that wave, right? Woo. Okay. So the domain here is, oh no, domain's all reals, right? The x coordinates. The range is -1 to 1. Okay? In other words, I can pick any value I want to plug in for x. And my output will always be between -1 and 1. All right, what about capital sign inverse? -1 to 1. And then this ends up being, oh no, negative pi over 2 to pi over 2. Okay? It's capital sign inverse, right? Make that a little bit bigger, a little more obvious. Now, what that means is that I have to pick a number between -1 and 1 to plug in here, right? Okay, that's the domain, -1 to 1. My output will always be between negative pi over 2 and pi over 2. Okay, the first thing that needs to happen is, because I'm taking sine inverse of sine, is that the output here has to be a value that I can plug in here. So my output from sine has to be able to be part of my domain. So this has to be a subset of this. In other words, everything in the range of the inner function needs to be in the domain of the outer function, which it is. My outputs here are always -1 to 1, and I can take the capital sine inverse of any number from -1 to 1. They don't have to be the same, but everything in the range of this function needs to be in this function. The other thing is that the values I pick here, right, I'm going to pick a value for x in the domain of sine. So I can pick, in this case, any number. That number needs to be my final output when I evaluate this. In other words, whatever number I pick here has to end up being able to be a solution of the final value. Is every real number in this interval? No. So as long as I pick a real number outside that interval, I can show that it's false. We could have picked pi. Well, you would need to explain, not just write down the domain and range for me, but explain, and really I would use this to kind of pick my number then. Oh, okay, I can pick any real number, and if I don't pick a number in here, then I'll end up with it not being equal. Does that make sense? Okay. But I want you to be able to analyze statements like this, the validity of them. Okay? Which is why we did all of those evaluations by hand to start with, so you get familiar with the domain and the range. Okay. They're not all like this specifically. Some of them are very much like this. Is capital cosine inverse of capital cosine of x always equal to x? Things like that. Okay, they're not always that way. If we were proving this to be true, then what we could say is, okay, the inner function's range is a subset of the outer function's domain, and the inner function's domain is a subset of the outer function's range. Okay, so everything here is contained in that domain, and everything here is contained in that range. And that would prove it for us, because whatever I pick, I'll plug in, and I'll get some value in that range. I can plug that into this domain, and then my output will be in that range. Okay, Mia. Right now.